on part 3 today, exam tomorrow, and then we have our last part 3 homework due tonight. So don't forget about that. Okay. So last time we were talking about how to measure accuracy of predictions that these 800-ish students made about these 10 events. And we came up with this total squared difference method that I did this example sort of by hand, where you were taking one of their guesses, like this first guess, subtracting the corresponding occurrence, which was a 0 or a 1, depending on if that event happened, and then squaring it. And then we essentially did this 10 times, once for each event, add them up. We call that the total squared difference. Now, the first question in the workbook actually wanted us to use that part 0 stuff, the summation notation, to rewrite all of this as a sigma notation, because this is annoying to write out. So the way we're going to do that works like this. So I'm going to consider person 14 for the purpose of this example. The book does this slightly different, but essentially what's going on is they call these guesses X values. But the way they tell the difference between, let's say, this row and this row is they give the X values 2 separate labels. And so if we look at the labels, the first number is the person's ID, and the second number is which guess we're on. So this is person 14's first guess, person 14's second guess, etc. That's why the X's have 2 subscripts. On the other hand, we only have 10 of these occurrences, so we're just going to call those like Y1 through Y10. They don't need 2 labels. And so if I translate that work we had when we did it by hand, utilizing these variables, it instead looks like this. We get a bunch of X minus Y's instead of 4.463 minus zeros squared. And then our goal is to rewrite all these X minus Y's as a sigma notation. And the way you do that is by trying to identify the pattern. So look what all these things have in common. They all have an X minus Y squared. The 14 is the same all the way across, but that remaining number changes as we go to the right. And so when you're doing a sigma notation, the only thing that changes, so like this 1 becomes a 2, which becomes a 3, we're going to replace that with a variable. And so down here, I replace that number with a j, and then I say that j goes from 1 to 10. And then this is equivalent to that guy right above it. And that is the sigma notation version for person 14. In the book, they have this generic person I, and so you would also replace the 14 with an I, but I thought it was slightly easier to use a number there, so because we already have enough variables. So that's what's going on there. There's also like a homework question about this concept, and so you just need to be able to like understand what each of these components are. The fact that this 10 means we're adding up 10 of these things. This first subscript is like the person's ID, and then the second subscript is sort of a placeholder for the events until we plug them in. So that's what it looks like if we change all this work to sigma notation. And then there's a question that says, okay, check out the occurrence tab. And they want to know, of these 10 events, what percentage of them occurred? In other words, what percent of them are ones? Well, I can count pretty easily. 5 of them are ones out of 10. So 50% of these 10 events occurred. Then there's a follow-up question, which says essentially, what would the total squared difference be if we had some hypothetical forecaster who put 50% for all their guesses? And so I use that exact same formula we've been using, where I take a guess minus an occurrence squared. I do that for each, each of them, add them up, and that would be the answer you'd get for the total squared difference if someone put 50% for all 10 of their guesses. So that's just one example of a total squared difference. What we were actually interested in is doing this exact same process over here with all this raw data. but I just did the same thing as before, just one at a time, looked at the squared difference between the first prediction and the first occurrence squared. You get 10 of these, and then you can add them up. Now, if you want to go a little bit quicker, there is a formula that does this without having to create these 10 columns. And I can show you that if you like, just ask me. But I wanted to do it this way just so you could see the steps involved of getting this total square difference. And if you want to check like these first 5 numbers or so against yours, if they match, you probably did it right. That's a good way to check it. Okay, so that was the first page of part 1, using the raw data that the spreadsheet gave us. The second page of, part 3, wanted us to round all this stuff. So what I told you last time was to copy essentially all of this to a new tab and then delete these numbers temporarily because I want to replace them with zeros and ones using the round function. And so we use the round function referencing the original numbers. So we use the round function on the original numbers. We change all these to zeros and ones, and we're essentially trying to figure out, does the first prediction after it's been rounded match the first occurrence? It does. That's 1 correct. And then we do it for the second one, the third one, all the way across. So again, I just did this one at a time. I used like an if statement that checked if these 2 things matched. And I used another if statement to check if these 2 things matched. And then I added up how many matches I have. So like the first person got all of them correct, except these last 2 don't match. So they got 8 out of 10 correct, and then drug that down. And again, if you check these first couple, and if you're getting those numbers, you probably did it. Then there's also one more question on part 2. It essentially said, of all of these numbers, how many are zeros? So you can do a count if on that. But what I would just all at once, but I would suggest doing, instead of doing it all at once, actually doing it 1 column at a time. So how many zeros and ones are in the first column? How many zeros and ones are in the second column, etc. Because the second question wants to know specifically, okay, you've counted all the zeros. How many zeros occurred? And what they mean by that is, if we look at these occurrence numbers, they mean how many zeros come specifically from those 5 columns that occurred. And so this is why I elected to count the columns individually, because now I can just pluck out these 5 numbers to see how many zeros were in the occurred columns and how many ones were in the occurred columns to get the answers to those questions. So like, for example, of all the ones that occurred, there's 4,000 of them, 2,500 of them happen to be in those 5 columns. And so of all 4,000 ones that people guessed, 63% of them were essentially correct. They were where they were supposed to be. And that's how we can answer that last question in part 3.